Hi, this is Yichen Sun, and I'm presenting to you my final project on time management optimization project. First, some background. In everyday life, we have different jobs to finish on every day. Some are routine work like exercising, some are course homework, and some are events we need to attend. In my project of optimization, I would like to optimize time management based on given constraints like working efficiency, deadlines, etc. We will use a genetic algorithm to solve for a heuristic optimization solution. And this problem is similar to some well-solved optimization problems like a knapsack problem or a single machine scheduling problem. We assign a value to each task based on their urgency and importance, which is very similar to that value in an abstract problem. And we also assign an assuming time for processing on each job, which is also like the cost in an abstract problem. And our time management problem is also similar in the way of scheduling, with different scheduling problems, like a single machine scheduling problem. Why I did this? First of all, I'm not a good time manager, and I really enjoy using some great time management apps. And I could modify my codes to extend it into a portable app in the future for personal convenience. Because constraints like deadlines and preference of the way to complete a certain job is easy to merge into the design of fitness function without changing the overall structure of the algorithm. And I could test the strengths and limitation of genetic algorithm and try to enhance its performance. The fourth reason is that permutation type of genome algorithm is not that many. My model, I will first evaluate every task, value of importance and value of urgency, and then add them up to attain the value of the task, like that. We have 8 jobs, and there are 8 modified value of the job, and there are 8 different times I need to take to finish different jobs, and there will return 2 vectors. And after that, I will assign every time block an efficiency factor, like this following way. In different time of a day, I have different efficiency, which indicates how efficient I am when I am completing jobs at that time. And we define a genotype by sorting all time blocks in a permutation way and assess its fitness by multiplying the value of the job in each time block to the efficiency of corresponding time block. And this is illustrated as below. We have 6 blocks. Each one stands for an hour, like one for 1 p.m. to 2 p.m., two stands for 2 p.m. to 3 p.m., so on and so forth. I have 2 jobs, A and B. One require 1 block, and second require 2 blocks. And for parent, like 531642, it means I finish job A in time block 5 to 6 p.m. and finish job B in 3 and 1 means from 1 p.m. to 2 p.m. and 3 p.m. 2 p.m. and 3 p.m. to 4 p.m. And with 2 parents, I perform crossover like the way we taught in the class and the permutation, and we return a new generation of offsprings. And for my code, I'll first read data from existing Excel schedule and setting parameters, evaluate a good initial population generated by a traditional algorithm, and the reason I will illustrate it later. And then initialize all population and do a really well selection, a crossover and a mutation, and then display the best of every iteration. My result, one of my result is as follows. I'll first explain to you why I have to set a traditional algorithm to solve for a traditional optimization result, because my optimization space is way too large. A single genotype has a length of 252 elements, and so when I perform crossover and mutation, their effects is relatively weak compared to my large optimization space, and and at the same time, my fitness function cannot return values of very different function fitness values. So selection is also not that strong. So comparatively, I cannot select to a very good result in a very limited time span. So I need to generate a good population at the beginning so that I can start from a very good beginning and I can return a better results in a very short time, like that. And my continuing work would be doing some dynamic scheduling. So whenever a new project and its constraint is added, a new schedule would be returned quickly. And I would like to restrict scheduling space into shorter time span, like future 10 hours, so we are likely to attain better results than current one. And we can also cooperate with other codes, different other codes, to generate some different, better initial population, so that we are likely to sort out and optimize result faster. And then we can extend the code into an automatic scheduling software. And the followed are my references. Thank you very, very much.